This is GATE 2013 question number 7, which states that the entropy function of a system is given by S of E, which is equal to A E E naught minus E, where A and E naught are positive constants. The temperature of the system is, so we have to comment on the temperature of the system if this is the entropy, which is a function of some E. Now, how will we understand what is E? We can check the options, what is written. So some options, if I read say A, negative for some energies, increases monotonically with energy, decreases monotonically with energy, and 0. So you can definitely understand from these options that this E, which is written here, is nothing but energy. Therefore, entropy is a function of energy, which is given by this particular function. We have to comment on the temperature of the system and then see that which of the options are correct. So let's see the step-by-step solution of this. Okay, so this is the solution. Given is that entropy, where S is a function of E. Now we have found out that this entropy is nothing but the function of energy from the options which are given, and the function is of the form this A E E naught minus E, where A and E naught are positive constants as mentioned in the question. Now from second law of thermodynamics, for reversible process we know that change in entropy ds is equal to dq by T, where dq is the change in heat. Now heat is nothing but a kind of energy. Therefore, we can write, instead of dq, we can write it as dE, where E is the energy. Okay, so this is the energy. Therefore, ds can be written as dE by T according to the second law of thermodynamics for reversible process. We have to assume that it is a reversible process, although it's not given. Now, ds is equal to dE by T. Therefore, ds by dE is equal to 1 by T. This we can easily get. Now, ds by dE, as S is the function which is given of E as this form, we just write and differentiate with respect to E. So ds by dE becomes ddE of the function which is given. I've just opened it, AE E naught minus AE square. That comes out to be AE naught minus 2AE. Fine. Therefore, ds by dE is 1 by T. Therefore, we can write 1 by T is nothing but this. Now T, therefore, is the reciprocal of this particular quantity. Therefore, that is T becomes 1 upon AE naught minus 2AE, where AE naught are positive constants as given in the question. Now let's see first what we can deduce from this particular function which we have found, which I have boxed now. From this, what we have found. First is, if AE naught, that this denominator, is equal to 0, then of course 1 by 0 T should tend to infinity. So at which limit that T should tend to infinity? So AE naught minus 2AE should be equal to 0. Then E comes out to be E naught by 2, because AA cancels out, it becomes E naught by 2. Therefore, E is equal to E naught by 2 is that point where T is tending to infinity. Fine. Second thing which we can deduce is that if E is less than E naught by 2, then what will happen? Say E is equal to E naught by 4. Then T becomes 1 upon A E naught minus 2A into E naught by 4. So 2 and 4 cancels, so get 2. And we get A E naught minus A E naught by 2, which is nothing but A E naught by 2. So T becomes 1 upon A E naught by 2, which is a positive quantity. Therefore, as E is less than E naught by 2, T is greater than 0. This is what we have found out. Fine. Now what happens if E is greater than E naught by 2? So if E is greater than E naught by 2, say E is equal to E naught now, which is greater than E naught by 2. Therefore, T becomes 1 upon A E naught minus 2A E naught. Instead of E, we have replaced now E naught. So this becomes minus 1 upon A E naught. Therefore, E greater than E naught by 2 limit will give us temperature to be negative. T is less than 0. Now what will happen if E equal to 0? Another possibility, that if E equal to 0, here if you put E equal to 0, then what will happen? It becomes T is equal to 1 upon A E naught. Fine. Now if E tends to infinity, then what will happen? If this tends to infinity, T will tend to 0. So this is a limit. T is tending to 0 only when E is tending to infinity. Therefore, we can draw this temperature with respect to the energy as this way. So this is T and this is E axis. So at E equal to 0, we have found out that T is equal to 1 upon A E naught, and therefore I have written here 1 upon A E naught at E equal to 0. So it starts from here. At E is equal to E naught by 2, temperature should tend to infinity. And E less than E naught by 2, we have found out E less than E naught by 2, T is greater than 0. And E greater than E naught by 2, we have seen T is less than 0. So this is, we have already seen. So E less than E naught by 2, since T is greater than 0, so it goes like this, because at E is equal to E naught by 2, it should tend to infinity. And this is what is shown in this figure. Now E greater than E naught by 2, we have got a limit that at E is equal to E naught, at E is equal to E naught, we have already found out that T is minus 1 upon A E naught. So at E is equal to E naught, T is minus 1 upon A E naught, which we have here. And as it tending to E naught by 2, it should go to infinity. And this is what is happening. And ultimately, as E tends to infinity, T is tending to 0 over here. So this is the plot. Therefore, from this plot, we can get certain things. That is, since there is a discontinuity exists at E is equal to E naught by 2, we cannot say that T increases or decreases monotonically. So T does not increase or decrease monotonically. Had there been no this infinitely going function, we can then say, but since there is a discontinuity present, we cannot say that T increases or decreases monotonically. Second thing, T is not equal to 0 at any finite value of E. Only when E tends to infinity, T is equal to 0. T is tending to 0. So T is not equal to 0 at any finite value of E. This is the second point we are getting. And we have found out that temperature is negative for some values of E. Even temperature is positive for some values of E. Now, from these 3 points, if we go to the question again, then we get negative for some energies. Yes, we have got when E is greater than E naught by 2, it is negative. So this is correct. Increases monotonically with energy? No. Incorrect. Decreases monotonically with energy? Again no, because discontinuity exists at E is equal to E naught by 2. And 0 only possible when E tends to infinity. Otherwise it's not possible, since there is no finite limit at which T is equal to 0. Therefore, we cannot say that T equal to 0. T should tend to 0 as E tends to infinity. Therefore, the more appropriate answer will be the A option, that is negative for some energies. So the correct option for this question is A, negative for some energies. Thank you.